Hello, this is Susan Poss. We are working in Chapter 2, learning how to solve equations. So I'm in Section 2.5. This is the first video. I'm going to divide this section into, I think, 4 different videos. So when you're solving linear equations, linear meaning first degree, means all the variables have no exponent higher than 1, or actually have an exponent equal to 1. When we're doing this, I like to be sure that students understand left side and right side. So I generally put in a little dotted line so we're clear what's on either side. And this particular equation has a variable term on each side. There's a 5x on the left, there's a 2x on the right. The constant terms are also on different sides. There's a positive 1 on the left and a negative 5 on the right. So our first task is to make sure that we get all the variable terms together on the same side. So I'm going to subtract 2x from both sides. Keep that equals mark right along that dotted line so you can track where you are. And then I'm going to subtract 1 in order to get the constant terms together on the same side. Again, keeping the equals mark. And then finally dividing each side by 3 to get the solution, x equals negative 2. Later on in this section, you're going to hear me call that a conditional equation because we got one unique answer. All right, so I think that's all we need to do there. Let's come down and try this next one. Again, making sure that everybody understands left and right sides. Again, I have variables on both sides and I have constant terms on both sides, so I'd like to match those up. I'm going to subtract 8y from both sides, and that has the effect of getting the variable terms together on one side. You can see that the 8y is now removed from the right-hand side. And then subtracting 5 from both sides. And then finally noting that we always divide by the coefficient in front of the variable when we get this down to this last step. I think I'll change color here. So I'm going to be dividing both the left side and the right side by this negative 6. So in this example, we're going to come up with y equals negative 5/6. Sometimes you will see that written with the negative in the numerator. That's acceptable too. And we'll go ahead and do one more very quickly. Left side, right side. Put in my little dotted line, noting that I have 2 variable terms, 1 on each side, and 2 constant terms, 1 on each side. And my purpose here is to try to move some things around so that the variable terms combine on one side. Notice how I'm keeping this equals mark in line there. And then I'm going to do the same thing with the constant. I want to move that 5 from the left side over to the right side by subtracting it. You'll notice how I'm using opposite operations. Notice I'm getting a 0 there. And then for my last step, remember we always divide by whatever this numerical coefficient is in front of the variable. So you're going to see me dividing both sides by 11. And again, remember that anytime you divide 0 by a number, you get 0. Don't confuse that with something that is undefined. It is undefined when you try to divide by 0. But when you're dividing into 0, you get 0. All right, so I think that's a good place to oops, I see one back up here. Let me say something quickly about this one. Notice in this one, we've got decimals. And they both are variable terms. I still want to get them both, the variable terms on the same side. So I'm going to subtract 8 tenths x. And of course I have 0 over here, and that's going to be similar to this last one that we just worked. When I take 0.8 or 8/10 and divide it into 0, I get 0.